Good afternoon, everyone. Today we're going to solve a system of linear equations by substitution and by elimination so we can compare and see the pros and cons of each method. So, our first equation, I like to number them 1 and 2. Our first equation is x plus 2y is equal to 33, and our second, 3x minus y is equal to 8. So, if we want to use substitution to solve a system of equations, we're always looking for step 1, isolating a variable. Right? Now, when you're asking yourself what variable should I isolate, the answer to that is really whichever one looks like it's the easiest to isolate. Okay. So one thing that I always look for is the coefficient of 1, right? So I'm going to make a note of that. Look for, let's say, most convenient coefficient, right? Most convenient coefficient. Obviously, positive 1 is pretty convenient. And so here we really have two candidates. We have positive 1 here, we have a negative 1 here, and they're really as easy as the other to isolate. I'm going to choose one with positive 1 because it's super straightforward, but again, you could isolate the y fairly readily. But in any case, I digress. Let's go ahead and isolate x. So isolate x in, let's say, equation 1. So if we do that, we're going to write x plus 2y is equal to 33, and now just some simple algebra of subtracting 2y from both sides means that x is equal to 33 minus 2y, right? So that gives us an equation for x entirely in terms of y, okay? Now we used equation 1 to isolate x, so we're going to plug this, we're going to substitute this in. Let's say step 3, substitute this in to equation 2, right? Always substituting into the equation we didn't use yet. Oh, excuse my off right here. Let me make this a little bit better. Substitute into equation 2, because we haven't used that one yet. It's equation 1, okay? So now x is going to be substituted, 33 minus 2y is going to be substituted into wherever x is in equation 2, so that will be here, and what will come out of that is going to be 3 times, again, instead of x, we're going to substitute in 33 minus 2y, okay? Whenever I do a substitution, I always put in brackets just to kind of keep things straight in my head of what I'm actually doing in my solution, and then the rest stays the same, so we have minus y is equal to 8. Now that we've done the substitution, it's just a matter of being careful with our algebra to work through it properly. So we're going to multiply the 3 through the bracket. 3 times 33, that's 99, minus 3 times negative 2y, minus 6y, minus y is equal to 8. And now, again, we're just looking at some algebra. We can combine like terms here. Negative 6y minus y brings us to 99 minus 7y is equal to 8, and now you can solve it. There's kind of 2 different ways. I'm going to subtract 99 from both sides, and so we'll have that negative 7y. Again, be very careful with your negatives. Negatives are such an easy way to make silly mistakes and to lose unnecessary marks along the way. We have subtracting 7y in our equation, and so when we get rid of the 99 on the left side, we still have that negative 7y, okay, on the left. And on the right, 8 minus 99 is negative 91. And now we can simply divide by negative 7 on both sides and have y be equal to positive 13. Okay? So we have the first half of our solution. We're not done. We only have the y value. It's going to solve the system of equations. We want to simultaneously solve both equations, and so we need y to be equal to 13. And now for x, we're almost at the end because we conveniently, we have an equation for x, right? We have x being equal to 33 minus 2y, and we know the value of y. And so we can plug it right into here and solve fairly straightforwardly. So let's go ahead and do that. X is equal to 33 minus 2. Instead of y, I'm going to plug in the value for y, and so minus 2 times 13. Again, anytime I'm substituting in a value into a variable, I put it in brackets just to kind of let myself know what I'm doing. And so we'll have x is 33 minus 2 times 13 is 26. and so x is equal to 7. And here is our solution. X equals 7, y is equal to 13. Solve both of these equations simultaneously, which is exactly what we're trying to do. Okay? Now, once you get the hang of things, this is my preferred way of solving these kinds of problems. You might prefer elimination. It really differs from person to person, but I really do think this is really efficient once you get the hang of things. Let's do elimination, and you can compare for yourselves. So when we do elimination, we're going to start off by writing the two equations stacked on top of one another, and this is where you'll really see the convenience of numbering them so that we can easily reference them in the process. And we'll have 3x minus y is equal to 8. Call that equation 2. And now, like the name suggests, the idea in this process is to eliminate one of the variables so that we're left with only one variable instead of two to solve for. And then we can do that much easier. So when we're looking for a variable to eliminate, we're going to look for a variable that has the same coefficient in both of the equations. Okay? Now, the way it's standing right now, neither of the variables have the same coefficient in both variables, in both equations. Okay? The x has a coefficient of 1 and of 3, and the y has a coefficient of 2 and of -1. None of them are the same. So what we can do is simply multiply either equation by a scalar multiple so we can create an equation that is equivalent, but that has a more convenient coefficient to work with. Just arbitrarily, I'm going to choose to eliminate the x. And so since we have a coefficient of 3 here and of 1 here, I'm going to multiply equation 1 by 3. Okay? Now this is going to create a new equation. It's going to be equivalent to equation 1, but it's going to look new. And so if we multiply all of this by 3, the entire thing by 3, let's say that creates equation 3. We're going to multiply every term by 3, so we're going to have 3x plus 6y is equal to 33 times 3 is 99. Right, you're going to start to see some numbers looking familiar, right? The 99 is what we saw here earlier on. So now we have equation 2 that we're going to use, and now we have equation 3 that we're going to use. And you'll notice that the coefficients of x are now identical. They're exactly 3 in the two equations that we're going to use to eliminate one of them. So now we can go ahead and subtract, since they're both positive, we can subtract equation 3 from equation 2. So I can make a note of that over here on the right side. We're going to subtract equation 3 from equation 2. And what's going to happen is that the x terms are going to eliminate themselves entirely. Hence the name elimination. So if we go ahead and do that, we can stack them up, do what we often do with subtraction. 3x minus 3x is eliminated completely. Now, negative y minus 6y is going to be negative 7y. And let's not forget the constant terms on the right side. Those are equally as important. We have 8 minus 99, giving us negative 91. And again, this might seem familiar, because this was precisely the last step of our process using substitution. So now we can finish this off by dividing by negative 7, divided by negative 7, right? And we find that y, again, is equal to positive 13. That's a good sign that we haven't made any silly mistakes along the way. If we get the exact same solution using both strategies, we're probably good to go. Or we've made 2 terrible mistakes. So now we have y equal to 13, which again is only half of our solution. We have to find the corresponding x value that goes along with it to solve both equations simultaneously. So now we don't have the convenience of having an equation for x in terms of y readily available, the same way we did using substitution. That's okay. We can use either of any of the 3 equations we have here. At this point, we just want to plug in the value for y that we found into one of them and solve for x using algebra. The answer to the question, which equation should I use, is quite simply whichever one looks the easiest to solve, whichever one looks the most convenient to solve. Just looking at them really quickly, I'm going to use equation 2. So I'm going to say sub n y is equal to 13 into equation 2. Okay. So equation 2 was 3x minus y is equal to 8. And so that means we're going to have 3x minus y is 13. So we're going to replace the y with its value of 13. And we're going to say that that is equal to 8. And now this is just rudimentary algebra. We're going to add 13 on both sides. So we get rid of the negative 13 on the left side. And so now we're left with 3x being equal to 8 plus 13 is 21. And of course, to finish that off, we'll divide both sides by 3 and find our solution for x of 7. So again, x into 7, y is equal to 13 is the solution, the unique solution to solving this system of linear equations. We get the exact same solution using substitution and elimination. So we're probably sure that we did this correctly, but it's always a good idea to verify your solutions. So to verify our solution, we're just going to plug in both values into both the equations to make sure that they're both properly solved. Okay, it doesn't take that long, so let's go do that. I'll do that up top here. To verify, we're going to plug in both values again into both equations. So let's look at equation 1 first. X is 7, y is 13, so we'll have 7 plus 2 times 13 is equal to 33. That's equation 1, right? Equation 1. So now 7 plus 2 times 13 is 26 is equal to 33. And 7 plus 26 is indeed 33. And so both sides turn out to be equal, which is great news. And now let's verify equation 2. Again, plugging in our values of y equals 13, x equals 7. In equation 2, we have 3 times 7 minus 13 is equal to 8. Again, just making note that this is equation 2. 3 times 7 is 21, so 21 minus 13 is equal to 8. And 21 minus 13 is in fact 8. And so 8 is equal to 8 means that both sides end up being equal to one another, which means that our equation has properly been solved. Okay? So naturally, you're going to eventually start to favor one method over another, just depending on kind of what your strengths and weaknesses are. You know, we find one more efficient. Again, I tend to lean towards substitution. Typically, I don't use elimination all that often. But you can see that, you know, if we have the right coefficients in place, it can be pretty quick. This drops down pretty quickly. And so sometimes it can save you a bit of time. Again, you'll play around with them and kind of build your own sense of comfort. But I hope this helps. If you guys have any questions, comments, suggestions, please do leave a note below. And thanks for watching.